So we have a wire attached to a telephone pole in such a way that the angle of depression, yada, yada, yada. Telephone pole is straight up and down. Obviously, there's going to be the ground. The wire is going to hook diagonally from the telephone pole to the ground. This is something that we don't understand most of the time when we see something like this, unless we've examined this situation, which most of you have not even considered doing. So this is the pole. This is the ground. This is the wire. All right, so it says the wire is 27 feet long. This is one of these rare cases that we know the hypotenuse. So the hypotenuse is 27. The angle of depression, okay, so again, here's this mixed in here. The angle of depression is not in that top corner where I got those dots because that's not from horizontal. The angle of depression would technically be right here, okay, but like we keep saying, the angle of depression and elevation are the same, so I'm not going to use the angle of depression. I'm going to use the angle of elevation in this because I want it to be inside of the triangle. So this is, again, a SOHCAHTOA problem because it has an angle involved with it. So I have to label stuff. That's the hypotenuse. That's the opposite. That's the adjacent. It says how tall is the telephone. I want to know that side. So I'm going to use the hypotenuse because I know it. I'm going to use the opposite because I want to know it, which means this is going to be a sine problem. So sine equals a fraction. The angle is 63. The opposite I don't know. The hypotenuse is 27. I know the angle. That means it's a cross multiply problem. Okay, so I need to go ahead and go to my calculator. Sine 63, 0.891. So 0.891. So x equals 27 times that number, 24.057. So 24.057. It says to the nearest hundredth of a foot. That means round to 5 using the 7. 24.06 is the nearest hundredth of a foot.